Okay, Algebra 2, Lesson 62, using complex numbers. This is actually a really, really helpful lesson. I would say that this lesson, in addition to what we'll eventually get into with logarithms, are a couple of those lessons that evaluate and your EOC really, really like to hammer. So this is something I'm going to say, you need to perk up, you need to pay attention, you need to take good notes. You should do that on any lesson, but I'm just telling you, I see a lot of this stuff on those state testing type things, okay? So using complex numbers. So if we see something like x equals the positive or negative square root of negative 16, what you need to understand is that that has no real solution. And so when we're talking about real solutions are in contrast to what you covered on like the first day of Algebra 2 or Geometry or even Algebra 1 is where we're talking about different number sets, okay? And number sets break down into a couple of categories. We have our first category, our major category, is real numbers, right? And under real numbers, we have rational versus irrational, right? Okay, and then under real numbers, we get into things like natural numbers, whole numbers, integers, right? Those types of things, correct? All right, and under irrational, we have things like pi and the square root of 2 and those types of things. So, what we're so used to is working pretty much predominantly within the real number sector, but what we sometimes forget is that what is the opposite of real? Imaginary. Which is it's this other side of things, okay? Numbers that don't actually exist, but things that we still work with anyway, okay? Which can be frustrating because you were already frustrated with the fact that we were substituting numbers with letters, and now we're taking numbers that don't even exist and we're working with those instead, right? Okay. So the square root of negative 16 is not a real solution because there are no real numbers that when squared are going to equal negative 16. Why is that true? Right, exactly. A negative times a negative is always a positive, so I can't multiply any two numbers and get the square root of a negative number. It's kind of like having an absolute value be equal to something that's negative. Can an absolute value ever equal a negative? No. Okay? But the equation does have solutions when a new set of numbers outside the real numbers is introduced, and we call these imaginary numbers. Okay? Now, these aren't hard to work with. You just kind of have to work under a different set of rules. An imaginary number is written in the form of bi. Bi. Okay? Where b is a real number. Okay? B in this case would act like a coefficient to a variable. Okay? Does that make sense? And where I is your variable, except I is not just a variable like x. I means something very specific. I is an actual imaginary number. Okay? I is the imaginary unit, and I is a solution of the equation x squared equals negative 1. I equals the square root of negative 1. What does I equal? It equals the square root of negative 1. What does the square root of negative 1 equal? It equals I. Those two things are substitutionary for each other. If I see a square root of negative 1, I can write I. If I see I could put in the square root of negative 1, although I don't normally do that. Okay? So the square root of a negative number is an imaginary number. So what I can do is I can factor out, whenever I see the square root of a negative number, I can factor out square root of negative 1, and that's going to look like I. So down here, what you see is the square root of negative 16, right? I can rewrite that as the square root of 16 times the square root of negative 1. Well, what is the square root of negative 1? I. And what's the square root of 16? 4. So I can rewrite that as 4i. Does this make sense? Okay, cool. What's that? Yeah, but I couldn't tell you. His question was, well, that would have been nice to know a couple of evaluate tests ago. Yeah, I realize. I just can't tell you guys what these things are. Otherwise, I end up throwing away, the validity of the test. So an imaginary number, bi, is part of a complex number. A complex number is a number that can be written in the form a plus bi. So a is a real number, and b is the coefficient of an imaginary number. Okay? It's that number that goes in front. But both a and b are real. In a complex number, a is called the real part, okay, because it's off by itself. And bi is called the imaginary part because, let's take, for instance, we'll take an irrational number like pi, okay? Can we have something like 4 pi? Yeah, we can have 4 pi. Pi is irrational though, right? Yes? Okay. What happens when I take a rational number and multiply it by an irrational number? What do I wind up with? I wind up with an irrational number. The same thing is true as whenever I take a real number and multiply it by an imaginary number, I get an imaginary number. Okay? So 4, which is real, times I, which is imaginary, is going to give me an imaginary number. Okay? You can kind of treat irrational and imaginary kind of like negatives, where the real number or the rational number is the positive. Well, I'm still going to get that negative part, or the imaginary, or the irrational. Okay, do you follow me so far? Okay. If b equals 0, though, then the imaginary part is 0, and the number is a real number, because anything times 0 is 0, and 0 is a real number. Okay? So that's kind of the exception to the real times imaginary. Okay? If a equals 0, though, and b doesn't equal 0, then I have no real part. All I have left is the imaginary part. Okay? So what you see down here is something like 2 plus bi. Okay? 2 plus bi is complex. 2 plus 0 times I is just 2, which means that's real. Okay? And then 0 plus 3i is just 3i. All I'm left with is the imaginary. So if all I have is a real number, it's called real. If all I have is imaginary, it's called imaginary. If I have both a real part and an imaginary part, we refer to it as complex. Okay? So I guess if you were in a relationship with an imaginary friend, we would call that a complicated relationship. Okay? If it's yeah. I mean, if you're in a relationship with a real person, it's just real, and we call that a real relationship. And I guess if two imaginary people are going out, it's just imaginary. There's nothing real going on there. All right. Glad I recorded that. To add or subtract complex numbers, add or subtract the real parts, then add or subtract the imaginary parts. So if I had something like 2 plus bi plus c plus di, I add the imaginary parts. And I think it's a little easier to see something like this written vertically as it is to see it horizontally. You see what I'm saying? Then I know I'm going to take a plus c, right? And I'm going to take b plus d times I. Okay, basically I is kind of factored out of the second part. Okay? Or you could do the same thing with subtraction. Okay, it's going to be a minus c, b minus d. Okay, does that make sense? I think it makes a little bit more sense to see it vertically drawn up. Okay. But we can add and subtract complex numbers. All right, let's look at a couple of these. All right, 7 times the square root of negative 99. Okay, what can I factor out of that square root of negative 99? Anybody? What can come out of there? I can take an I out. You know, be careful when working with imaginary numbers. You'll have to take your eye out. All right, so we would say, we could rewrite that as 7i times the square root of 99 now. Okay, can I factor down, can I find the square root of 99 or simplify the square root of 99? Well, I mean, what do I have in here? I got, what, 3 and what? 3 and 11? 3, 3 and 11. So I got what? 3 and 33, 3 and 11. What can come out of that though? I can only take a 3. So I'm getting 7i 3 square root of 11. Can I simplify in here? Remember, this is all multiplication, so 3 times 7 is 21. So we would take 21i radical 11. Does this make sense? So far, so good? Okay. Okay, we have something that looks like 2x squared plus 18. We want to write the solutions in terms of I if necessary. Okay, so what we're going to do here is we're actually going to use, what I would use in this case is I would use the quadratic formula. Okay, so 2x squared plus 18 equals 0. Let's go to a separate page to kind of look at that. Okay, what was that? It was 2x squared plus 18 equals 0, correct? Okay, well that would be what? 2x squared plus 0x plus 18 equals 0, right? Or actually, I think we can do this a little bit easier. Because really we just want to solve for x, correct? All right, and doing that, all we really need to do is isolate x. What would you do to begin doing that? Subtract 18 from both sides. Okay, so we have 2x squared equals negative 18. What would you do now? Divide by 2. So you're getting x squared equals what? Negative 9. What do you need to do to both sides now? Square root. Square root. So x equals the square root of negative 9, right? What can I take out of that? I. Okay, so I got x equals I radical 9. Can I square root 9? What do you get? I get 3i. Okay, let's come back and let's see if that's a possibility. Okay, and let's see. We should be able to, and I'll explain this. Let me go back here and explain. Anytime I have x squared equals the square root of a number, okay? So x squared equals something like this, okay? When I go to square root this, my answer is automatically x equals the positive or negative square root value of that number, okay? So what we should have had down here is x equals the positive or negative square root of 9, positive negative square root of I radical 9, or positive or negative 3i. So hopefully, if I've got that right, we'll come back here. Positive or negative 3i. What is the answer on 2? Can you guys scroll down to that? Is it A? I mean, that's what I got. Okay, but that's one rule that you want to be careful of. If I have x squared or b squared or z squared, whatever it is, equals something on the other side, and I have to square root my variable to find my solution is automatically both positive and negative. Because remember, negative times a negative is a positive. Okay, and that was a positive x squared to begin with, correct? Okay. All right. Let's see here. Number 3, we have 6 plus 5i plus negative 4 plus I. So would it be easier to rewrite this in that vertical format and see how this works? Okay, so 6 plus 5i plus negative 4 plus I. Okay, so what do I do first? 6 minus 4, which is 2. Okay, and I'm doing 5 plus what? 5 plus 1. Okay, so what should I get? 6i. 2 plus 6i is C the answer? Hopefully. Okay, so I think it's a little easier to see that one on top of the other as opposed to trying to remember that I'm going to do this and this. Okay, because if I see this and that, I'm automatically thinking FOIL, and that's going to mess me up. So I rewrite it vertically. Okay, do you guys want to go to some questions in your book before we close out and give you guys some time to work? Okay. All right, let's do that. I'm going to go over to a blank page. If we pick something out. G. Okay, so it says, let's see, let's get it right up on the board. X squared minus 2x plus 2. X squared minus 2x plus 2 equals 0. And what does the instruction say? It says solve each equation, write the solution in the form of a plus bi. Oh wait, you said g, right? Well, I was looking at h, sorry. X plus 9 squared equals negative 9. What do we say? X plus 9 squared equals negative 9. Okay. So if we wanted to solve for x, where would you start? All right, we're trying to isolate x, so we're going to have to undo some things. What's the first thing that we can undo? We could square both sides, right? Could we do this? That might be simpler. All right, so that would give me x plus 9 equals the square root of negative 9, right? Yes? Okay, now what would you do? Let's go ahead and get everything over on the other side first. So I'm getting x equals negative 9 plus the square root of negative 9, right? We'll see if I'm right. I could be wrong about all this. So that's going to give me negative 9 plus what? Okay, so I can take what out of that? I, and that's going to leave me with the square root of 9 now, right? What's the square root of 9? 3, so I can write that as 3i. Okay, let's see if I can find in here. Okay, now the only thing that we did not do, does anybody know what we didn't do? We needed this plus or minus, plus or minus here, plus or minus here, plus or minus here, plus or minus here, minus there. So really easy to forget to do that. Okay, anything else? No, we feel good about this so far? H, okay, so we want to see that H now. All right, what was this? This was G. Go ahead and label that. H, Danielle, can you read that? It was what, x squared? Okay. Okay. This one I would do as a quadratic formula. Quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Are we fairly familiar with that? Okay. So what we're going to do, notice that this is a negative 2. That b is a negative 2. So what am I going to write in my formula? Negative 2 or positive 2? Positive 2, because this really just means the opposite of b. Plus or minus, okay, square root of negative 2 squared minus 4 times 1 times 2. Does everybody understand where those numbers come from? Okay, hopefully. All over 2 times 1. All right, now we need to go ahead and do some of the math inside here. We've got 2 times 2, which is, or negative 2 times 2, which is 4, and minus 4 times 2. So I actually have 4 minus 8, right? Negative 4 divided by 2. All right, now I need to simplify that square root of 4. Okay, Jewel, what can I take out of that square root of 4? I can take out a 2. But remember, there's a negative here. So what does the negative become? No. What, guys, what do I take? What do I substitute from that negative? I. Okay? Think of it like this, Jewel, is that it's the square root of 4 times the square root of -1. And what is the square root of -1 the same as? I. So I'm going to substitute square root of 4. I'm going to get I there. What is the square root of 4? 2. So I'm left with 2i. So I'm getting 2 plus or minus 2i divided by 2. Can I simplify that, Axel? Okay, what do I get? 1? No, I'm dividing everything by 2's. Or just I. Okay? Because it kind of acts like a variable, even though it means something specific. So I can leave it just like that. Okay? All right, so that's G and H. And I'm going to stop our video right there.